Okay. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to go on and take a look at section 6.6, which doesn't have anything new. It just puts it all together. So I'm going to make a list here in a minute that we're going to follow. But before we do you have any questions, anything you want to look at?
Nope. I asked the question I had yesterday. I just got confused. That's all.
Okay, that's all right. All right. So here's a list. And this has to do with the order that we're going to deal with polynomials when we're trying to factor them. Okay. And strangely enough, my list starts with item 0.5, which I will explain in a bit. So I'm going to call item 0.5 standard form. Okay. Then item number 1 is take out greatest common factor. Item number 2 is, let's see here, I'm going to say binomials look for the difference of two squares. Okay. Item number 3, trinomials, and we're going to have Roman numeral 1, perfect squares, Roman numeral 2, x squared plus bx plus c, Roman numeral 3, ax squared plus bx plus c, and this is going to be grouping or trial and check. Item number 4 is factor by grouping. Item number 5 is check your, wait, I was wrong. Item number 5 is, are you through? And then item number 6 is check your work. This is supposed to be a, we'll just go ahead and write check. All right, so this is a list. It's important to follow the order of it. And let's see, the standard form, I'm going to do this. I'm going to add this little arrow thing here. It's not really an arrow, but standard form is important if you're dealing with a trinomial or a larger. If you're dealing with a binomial, more importantly than standard form is, can you write it as a difference of two squares? We looked at a problem yesterday where one of the ways we factored out a -1 and the other way we just switched the two terms around. So with a binomial, we're not so much concerned about standard form as we are difference of two squares. Okay. I'm going to refer back to this list as we look at problems. All right, you ready to go on? Hopefully.
Yes, I am.
All right, excellent. There's also a list in the book. It's slightly different from this. It's in the reading at the beginning of section 6.6. So if you don't like my list, you can follow their list. Won't hurt my feelings a bit. All right. So let's take a look at this problem. 2b squared plus 8b minus 24. All right, this is a trinomial. So standard form is a big concern. Is it in standard form? Yes, it is.
Yes.
All right. So it's in standard form. Is there a greatest common factor? Yes, there's a 2.
Yes.
So we'll take 2 out.
To make sure my mic was on for a second.
Okay. So b squared plus 4b minus 12. All right. Now, what's left in parentheses? Is it a binomial? No. Is it a trinomial?
No.
Yes. Okay.
Yes.
So, is it a perfect square? No. Does it have a leading coefficient of a 1? So it's in the form x squared plus bx plus c. Yes. So we're going to do this. Product is -12, the sum is 4. So that's out of section 6.2. So my two numbers are 6 and -2. Are you okay with that, or do you want me to go into details about finding them?
No.
Okay, that was a sad looking B. All right, so I've got +6 -2. Now, when the leading coefficient is a 1 and I do this, the numbers go right into the answer. I don't have to use grouping. Okay, so are we through? Is there anything left? We've got a couple of binomial factors. For instance, b -2. Is that the difference of 2 squares? No. So we can't factor any further. So we're through, except to check our work. So let's see, we've got 2b plus 12 times b -2, which is 2b squared minus 4b plus 12b minus 24, combine like terms, 2b squared plus 8b minus 24. It checks. So this is the correct answer. All right with that? Okay.
Yeah.
Let's take a look at another problem. Let's see here. 32 minus 2t to the 4th power. Now, this is not in standard form, but it is a binomial with a subtraction sign. So rather than switch things around, I think I would just leave it because it's in the form of a difference kind of thing. It's not the difference of 2 squares yet. We can take out a greatest common factor of a 2. Now we can take 16 minus t to the 4th and write it as 4 squared minus t squared squared. So we get 2 times 4 plus t squared times 4 minus t squared. Are we through? No, because this is also the difference of 2 squares. 2 squared minus t squared. So we get 2 times 4 plus t squared, 2 plus t, 2 minus t. Well, but what about this factor? That's the sum of 2 squares. There's no greatest common factor to remove, so it won't factor any further, will it? So we don't say the whole thing's prime, but we can't factor that any further. Okay, so this would be the final answer. Any questions about that? Now, you could take this, switch it around and write it -2 t to the 4th plus 32, factor out a -2, blah, 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 factor it, and you'd get an equivalent answer to what's in the blue box down below. Do you want me to do that, or are you good with this?
I'm good with that.
Antonia, how about you? You good with that? Okay. We'll take your silence as a yes. Let's see here. 6r squared plus 3rs minus 18s squared. This is a trinomial. It is in standard form in terms of the variable r. It's not in standard form in terms of s, but if it ain't broke, don't fix it, right? Okay. Is there a greatest common factor? Yes.
Yes.
3. So we'll take out a 3. 2r squared plus rs minus 6s squared. All right. What's left inside is a trinomial. It's not a perfect square. It doesn't have a leading coefficient of a 1. So we're either going to use grouping or trial and check. Which do you prefer?
Either is okay with me.
Okay, well, I'll use grouping then. So A is 2, B is 1, C is -6, the product is -12, the sum is 1, the numbers are -4 and +3. Oh, no, they aren't. My bad. The numbers are 4 and -3 because I need to get a +1 as a sum. Okay. 3 times 2r squared plus 4rs minus 3rs minus 6s squared. So again, we took the middle term, split it up using those two coefficients. So now we continue with the factoring by grouping. The greatest common factor of the first two terms is 2r. The remainder leftovers is r plus 2s. So over here, I'm going to have r plus 2s. And outside, I'm going to have minus 3s. So now I've got 3 times r plus 2s times 2r minus 3s. Well, I have a binomial with a subtraction sign, but it's not the difference of two squares. So there we go. Any questions on that one? Okay. T minus 90 plus t squared. This is a trinomial, but it's not in standard form. So we've got t squared plus t minus 90. So now it's in standard form, okay? Is there a greatest common factor we can take out? No. Is it a binomial, difference of two squares? No. Is it a trinomial? Yes. Is it, let's see here, is it a perfect square trinomial? No. Does it have a leading coefficient of a 1? Yes. So it's in the form x squared plus bx plus c. So we're going to split up the leading term. Product is -90 and the sum is 1 because there's an implied 1 as the coefficient in front of t. Okay. I think I've mentioned this before, but in case I haven't, WebAssign doesn't like you putting implied 1 coefficients. It marks it wrong. It shouldn't, but it does. So don't put a 1 in front of the t kind of thing. All right. Now, how about 10 and -9? That's a product of -90 and a sum of 1. So plus 10 and minus 9. Any questions about that problem? Okay, let's take a look at this one. And if I need to slow down for you to write more, let me know. I'm not in any hurry, not going anywhere. Okay, let's see. What have we got here? we've got a b squared minus 4a plus 3b squared minus 12. Well, that's 4 terms. What do we typically do with 4 terms? Factor by grouping. Oh, I wanted to point out why I started with 0.5, because if I start with 0.5 on my list, then 1, take out the greatest common factor. 2, binomials have 2 terms. 3, trinomials have 3 terms. Factoring by grouping typically has 4 terms. That's all. Okay. You're supposed to be impressed by that. It's okay. You don't have to be. All right. So let's take this and use factoring by grouping. But first, is there a greatest common factor for all 4 terms? The answer is no. So factoring by grouping, the greatest common factor of the first 2 terms is a. The leftovers are b squared minus 4. So on the right side, the leftovers are b squared minus 4. And we have a plus 3 outside. So now we've got b squared minus 4 times a plus 3. Are we through? No, because b squared minus 4 is the difference of 2 squares, right? That's b squared minus 2 squared. So this is b plus 2 times b minus 2 times a plus 3. All righty. Let's see here. Let's take a look at another one. 16 minus 40z plus 25z squared. This is a trinomial, so we want standard form. 25z squared minus 40z plus 16. There's no greatest common factor, and it's not the difference of 2 squares because it's a binomial. So it's a because it's not a binomial. It's a trinomial. Let's see. Is it a perfect square? Well, it starts with a square, ends with a square, and there's a plus sign in front of the 16. So it's a good potential candidate. 25 would be 5 and 5, and z squared would be z and z, and 16 would be 4 and 4. But the middle term is negative, so to achieve that, these would both have to have minus signs. Well, let's see. 5z times 5z is 25z squared, and minus 4 times minus 4 is plus 16. But what about the middle term? That would come from this one and that one. Well, minus 4 times 5z is minus 20z, and 5z times minus 4 is minus 20z. And if we add those together, we get minus 40z. So it's a perfect square trinomial. And there is our answer. Or we could write it 5z minus 4 the quantity squared. So either way. All righty. Let's see here. How about this one? Negative 20m cubed minus 100m squared minus 125m. Well, this is a trinomial, and it's in standard form. Greatest common factor. My leading term is negative, so I'm going to take out a negative. 5 would be the greatest common factor of the 20, the 100, and the 125. And then I can take out an m. So my greatest common factor would be negative 5m. Leftovers would be 4m squared plus 20m plus 25. Well, let's see. What's in the parentheses? There's a trinomial. Looks like it might be a perfect square. So let's see here. 2m, 2m, 5, 5 plus 10m, 10m. Yep, it's a perfect square. So that's the answer. Or you could write it like this, negative 5m, 2m plus 5, the quantity squared. All righty. Let's see here. How about this one? 6x squared minus x minus 16. This is a trinomial. It's in standard form. There's no greatest common factor. It's not a perfect square. It doesn't have a leading coefficient of a 1. So we're going to use grouping or trial and check. Okay. Karina, you said you didn't care. You other two, do you have any preference as to whether I use the grouping method or the trial and check method?
No, either.
Either one. Okay, I'll go ahead and use grouping then. A is 6, B is -1, C is -16, product is -96, sum is -1. I need two numbers whose product is -96 and whose sum is -1. So this is what this tells me. I'm looking for a positive number and a negative number, one of each. But when I add them together, it comes out -1, which means those two numbers, their absolute values, if you will, are just 1 apart. So what times what would equal positive 96? Well, what I'm going to do, I'm going to go to my calculator and I'm going to find the square root of 96. It comes out to be 9.7. Okay. 9.7. So 9.7 is close to 8 and close to 10. But the bigger one's got to be negative. So how about -10? No, that doesn't work, does it? -10 doesn't go into that, but the -8 would. So -8, that goes in what, 12 times? Oh, but wait a minute, the bigger one has to be negative, right? So -12 and 8. Boy, I don't know. Let's attack this a different way. Let's not do the old square root and start in the middle. Let's start at one end. How about -96 and 1? That would give you a sum of -95, right? I'd have the right product, but the sum would be -95. Well, -96 is even. Let's cut it in half and double that. That would be -96 as a product, and the sum would be -46. Let's cut this in half and double that. That would give me a product of -96 and a sum of -20. Well, let's cut this in half and double that. That's going to give me a sum of, or a product of -96 and a sum of -4. I'm getting so close. Well, if I cut this in half and double that, now I've got a positive number that's bigger than a negative number, and we determined the negative had to be bigger, but I could switch this around. Okay, what does that give me? -10. That's going to go back up here. So let's look at what's happening here. I'm going to erase this stuff. So this keeps getting less negative, right? And this keeps getting more positive. And I'm getting closer and closer to -1. So is there anything in here? Is there a number that's less negative than -12 that goes into -96? Well, let's see. -11 doesn't, -10 doesn't. -8 does, but we already determined that that isn't going to work because the positive number needs to be smaller. Any ideas? Anybody? It's prime. Can't find anything that's going to work. It's prime. Well, that was kind of a mean trick, wasn't it? Oh, well. All right, let's see how we do it. That. Let's take a look at this one. AC plus BF plus AF plus BE. Well, there's no greatest common factor other than 1, so let's try grouping. What's the greatest common factor of the first two terms? Just a 1. So I could write it like this, I suppose. But then this would have to be that. That's not going to work, is it? Oh. Any suggestions?
Could we rearrange it?
Bingo. Let's see. Let's go AC plus AF plus, how about this? Wait a minute. Did I copy something wrong? I think I did. Hang on, let me find this problem. Oh, here's what I copied wrong. My bad. This is supposed to be an E. Okay. It doesn't change things. We still couldn't have factored it the way it was. But I've got my E's here and my F's there, so I'm going to do this. Okay. So I'm going to put the A times the E plus the A times the F, and then the B times the E plus the B times the F. Why is that going to work out nicely? Because now I'm going to have A times E plus F, and over here, E plus F and a plus B outside. So then I've got E plus F times A plus B. So sometimes you have to move things around to get them to work out right. Okay. Let's see here. How about this one? X to the 6th power minus 4x cubed minus 12. Well, this is a trinomial. It's in standard form. There's no greatest common factor. It's not a perfect square. It does have a leading coefficient of a 1. But we're not breaking apart x squared. We're breaking apart x to the 6th. So we would do that. Now the product is -12 and the sum is -4. So -6 and 2. Is that going to give us what we need? Yes, it is, because look, we'll have x to the 6th in front, -12 at the rear, but we'll have -6x cubed plus 2x cubed, which is -4x cubed. So this thing factors like that. All righty. How about this one? 25b squared plus 14b plus 49/25. That doesn't look fun at all, does it? Okay, well, it's a trinomial. It's in standard form. Doesn't appear to be a greatest common factor. I wonder if it's a perfect square. Let's see. We'd have 5b and 5b. 49/25 would be what? 7/5 and 7/5, right? 7 times 7 is 49. 5 times 5 is 25. The middle term's positive, so a plus and a plus. Well, let's see. I've got 25b squared at the front, and I've got 49/25 at the rear. But what about that and that? Well, let's see. 7/5 times 5b would be 7b. And 5b times 7/5 would be 7b. And 7b plus 7b is 14b. So by golly, Miss Molly, we've got a perfect square trinomial, which you could write that way, or 5b plus 7/5, the quantity squared. All righty. Okay, here's another fun one. You're going to love this one. 1/4 minus u squared over 81. Well, that's a binomial with a subtraction sign. I wonder if it's the difference of two squares. Well, the square root of 1 is 1, the square root of 4 is 2, the square root of u squared is u, and the square root of 81 is 9. It is the difference of two squares. Do you see that? Maybe. So this would be 1/2 plus u over 9 times 1/2 minus u over 9. And let's see here. How about this one? X squared y squared minus 6xy minus 16. Well, this is a trinomial. It is in standard form in terms of the variable combination xy, because here we have xy, the quantity squared, and here we have xy, and here we have no x or y at all. There's no greatest common factor. It's not a perfect square, and the leading coefficient is a 1. So it's going to look like this. Product is -16. Sum is -6. -8 and plus 2. There you go. Well, I think I've tormented you enough for today. So for tonight, you've got section 6.6. And I would advise you to memorize this or some form of this list. So it's up here, so you kind of have a checklist as you're going through these problems. I'll be back this afternoon at 1:15, and should you have need of me, otherwise have a great day, and I will see you tomorrow.